Good morning, everyone. Hope y'all are doing well this morning. All right. Did everyone have any questions over section 3.2 or 3.4? All right. Today we're going to wrap up the material for chapter 3, and and so that'll be. I think we already did all the material for 3.4. I just wanted to make sure I work another example and clarify a little bit. But then we'll look at section 3.5 today, and that'll be it. Which means that next time on Tuesday we'll be reviewing for our test, and then after that I'll make the test available, and you'll have about a week to over which you need to do it. But we can talk a little bit more about that on Tuesday, or at the end of the class today if we have time. Let's see. So, I wanted to do one more problem with section 3.4, which is on finding quartiles or percentiles and testing for outliers. We looked at our 20 data value set with the ages of stat students, and we did find that 45 was an outlier in that group, and so let's look at another example, and for this we'll go back to our Fibonacci data. And I'll go all the way to 34 this time. Okay, now in this set of data, if we want to find the median, we know that the median already is the middle value. So the middle value in this case, we just start from either end and start working our way in until we get to the middle, which is the 5. So 5 is our median. So what if we wanted Q1? Well, in this case, Q1, the first quartile, or again, the 25th percentile, this is the median for the lower half of the data set below the median. Let me say that again. We take the lower half of the data set below the median, and we find the median of these four numbers now. So the median splits the data in half, so we want the middle half of the lower half, which would be the 25th percentile. Because now this represents 0 to 50, so we want the 25th. So what would be the median of these four numbers then? $1.5, yeah. So Q1 is the median of the lower half so 1.5 is Q1. Okay, and then by the same reasoning, we can say that the Q3, the third quartile, or the 75th percentile, is the median of the upper half of the data. So for these four values, which number represents the median there? Do you want to have that? $17, good. Okay, now, so if we wanted to do, find the quartiles without using a calculator, this would be how we apply it. Okay, so we find the midpoint of the entire data set, that's the median, and then we look at the half of the data set below that median, find its midpoint, and we find the half of the data set above the median and find its midpoint, and that would be our other quartiles, Q1 and Q3. So there is a logic there, and then certainly if we have a lot of data values, it's going to be a lot easier on the calculator than it is by hand, but I just wanted to make sure I showed you the by hand approach as we did with everything else. Now the other question here, are there any outliers in this data set? Well, it depends. First thing we calculate is what we call the interquartile range, which is defined as Q3 minus Q1. Basically the distance between the first and the third quartile, or the range if we want to call it that. In this case, we said 17 was Q3, 1.5 is Q1, so we'll just subtract those. And that gives us 15.5. Okay. Next, we find the fences. The lower fence is Q1 minus 1.5 times the IQR. Q1 is 1.5 already. And from that we want to subtract 1.5 times 15.5. So that gives us a value of negative 21.75. And that's our lower fence. Now we may think it's odd to see a lower fence be negative, but if, especially if we look at a data set where all the numbers are positive. What that really tells us when we have a negative lower fence like this is that the data is actually really compact on the left side of the data set, meaning the values are pretty close together compared to the rest of the data. Okay. The upper fence would be Q3 plus 1.5 times the interquartile range. So plugging Q3 is 17 plus 1.5, and then 15.5 is the interquartile range. So our upper fence is equal to, and we'll go 17 plus parentheses 1.5 times 15.5. And so that gives us an upper fence of 40.25. Now, to determine if there are any outliers or not, we say an outlier is any number that's lower than the lower fence in the data set, or any number that's higher than the upper fence in the data set. So we look at our data. Are there any values here that are lower than negative 21.75? Well, no. 1 is our lowest value. That's our minimum value, and it's certainly inside the fences still. And an outlier would be anything higher than 40.25. Is any value here higher than 40.25? And again, the answer is no, because our highest value is 34. Now, this is a lot closer to the upper fence, meaning that the values on this side are probably get a little bit more spread out compared to the left-hand side, which with this particular number sequence, this is exactly what happens. I don't know that it ever ends up being outliers, though. Anyway, that's not related to what we're covering. So we can say now that we may have suspected 34 as being an outlier, but it turned out it's not an outlier by the way in which we defined outliers. Okay, so again, all the data values are between the two fences, so there aren't any outliers. So we can think of the fences as quite literal fences. It's kind of keeping all of our data between the two fences, All right. So that's another example where we can, I wanted to show you how we could work that by hand rather than just with the calculator. Now, certainly if we go into the calculator and we enter all of our data values, I'm just going to clear everything. Okay, so we have 1, 2, 3, 5, 8, 13, 21, 34. Okay, then we go second stat, 1 var stats, 1. Okay. Okay, we see the Q1 is actually 1.5, as we said. Median is 5, and Q3 is 17. That agrees with everything that we said up here. So that's how we're actually calculating those values, but doing it by hand, I think, helps us see a little bit better what it is we're actually talking about when we say Q1, median, and Q3. Does anyone have any questions? Okay. All right. Now, moving on to section 5. Section 3.5. Let me see what the title of this thing is. 5-number summary and box plots. Okay, now we'll talk about the 5-number summary first, and that's actually something that we've already discussed all the elements for, but we've never really given it a name. So let's look at the 5-number summary. Five-number summary consists of 5 values, as we may suspect. And these are the minimum, the Q1 value, the median, the Q3 value, and the maximum. So, after section 4, we've now talked about every single one of these values. We talked about the minimum, the median, and the maximum in the early part of the chapter, and then we added Q1 and Q3 in the most recent part. Now, from a visual perspective, percentiles, these 5 values basically split the data set into 4 equal pieces. Okay. Now, basically saying, okay, there's as many values between the minimum and Q1 as there are between Q1 and the median, as there are between median and Q3, and between Q3 and the maximum. So, basically, these 5 values split the data set into 4 equal pieces as far as the number of data values that are there. Now, what it doesn't say is that, how close these values are together or how far they are apart. But that is actually something that will help. This will help us illustrate. If we have a very compact set, then all 3 of these middle values should be pretty close together. Okay. And then depending on what happens with outliers, we may have these 2 on the outside be further apart. If we have a very spread out set, then there will be a good amount of distance between each of these. Okay. So, that's our 5-number summary. And again, when we look at our calculator, both on the graphing calculator and this smaller one, The 5-number summary is basically all the last 5 values that it gives us in these statistical calculations. Okay, both of them end with the 5-number summary, so that's already something we know how to find in the calculator because we've found it already for different things. The question then is, how do we use this? Well, this is where the box plots come in. Now, a box plot, sometimes in other textbooks you'll see this referred to as a box and whisker plot. Because the general visual that we get is a box in the middle with just a single whisker on each end coming out. But a box plot uses the 5-number summary as well as any outliers to create a visual representation of the data set. Also, we use the fences, depending on how intricate of a box plot we want to make. Now, we can make a simpler box plot that only uses the 5-number summary, or we can make a more elaborate one that also includes the fences and outliers. So I'll say, and sometimes the fences and outliers to create a visual representation of the data set. Okay. And by looking at these visual representations, we can, if we're taking like multiple samples from the same population, we can use these box plots for each of the samples to compare them to each other in some cases and see if there's any similarities or fundamental differences. Or we can just use it to look at how far data is spread out versus how compact it is. The box plot will also indicate whether the data is skewed to one side or another, and so we can use it in that regard. So the way that a box plot looks will be something like this. And before we actually find one, I wanted to give you a basic sketch. We'll have a line on which we mark our 5-number summary. Okay, minimum, Q1, median, Q3, and a maximum. And one thing we like to do with this line is we want to make sure that they're equally, like the numbers are equally spaced, so it's taking place on a number line, for example. So maybe down here I'll have a number line, and these are all marked equally, saying, okay, these are the values that are being represented here. Okay. So that actually, that way we know when these 2 points are closer together than these 2 points, that actually will tell us something about the data. Now we draw vertical lines through the middle 3 points, the Q1, the median, and the Q3, and we close up a box on top and on bottom for those 3 pieces. Okay? So again, this is the median, and we have Q3 and the maximum. Here is Q1 and of course the minimum. Now, just looking at this particular box I've drawn, this data, I would say, looks a little bit skewed left. And the reason I would say it's skewed left is that the distance from the median to Q3 is shorter than the distance from Q1 to the median, and the whisker between Q3 and the maximum is shorter than the whisker from Q1 and the minimum. Okay, that means most of the data is centered on this side of the graph, and we have a longer tail going off to the left, which would meaning it's skewed left in that case. Now, for determining if something is skewed left or right or symmetric, I would still prefer that you compare the median to the mean. That way we have actual numbers to back up our claim. But sometimes it can be a little obvious from the box plot itself what is actually happening here. Now this one, it may not be a pronounced enough difference to say it actually is skewed, but it certainly looks that way based on what we see here. The relative size of this piece to this piece, and from this piece to this piece. As far as whether this data is compact or spread out, I would hesitate to make that judgment looking at this picture because it looks fairly evenly distributed. If we have much shorter whiskers on each side and a larger box, then that means it'll be a little bit more spread out. And if the box is relatively small compared to the whiskers, then we'd have a very compact data set, so, or more compact. This one, it looks kind of in between, honestly. So. Anyway, now I mentioned that we might also use the fences and the outliers. The way that we use the fences is we'll draw the fences with a bracket. So this might be the upper fence, and this might be the lower fence. Now, what happens is that since the upper fence is higher than the maximum, there aren't any outliers on this side of the data. On this side, though, because the minimum is lower than the lower fence, that means the minimum is an outlier, so we can label it with an asterisk. Okay. So the asterisk means outlier. So that's how we can make a little bit more descriptive of a box, including this additional information for the fences and the outlier. And there may be more than one outlier. Like if we have two values that are both the minimum, then we would put two asterisks there. And it may be that we don't have any outliers, and then the entire line is between the two brackets for the fences. So it depends on the data set, really. So what I want to do now, let's go back to our 20 value data set we were working with before and create a box plot for that data and see what it tells us. Now, we've already done quite a bit with that data set throughout this chapter. So I think it will, I mean, a lot of these things we've already figured out. Yeah. I saved the data set in my phone from the last time I wrote it on a whiteboard. So there it is. Alright, so our data (18, 21, 37, 18) all the stuff that we've done with this data set throughout this chapter kind of simulates how it's going to appear on the review. Because for the review, you predominantly will work with one data set for the chapter 2 and 3 material, just as we've done as we've gone through and studied all this stuff. Okay. Trying to get the camera to focus. There we go. All right. So once again, we'll enter our data into the calculator. I think when we first looked at the calculator, I already had the data in there, and I managed to delete it, so that's my bad. I'm just going to go by column: 18, 21, 37, 18. Make sure I hit that 0. 18, 32. Come on. 21. Yeah. Okay. So I get it all into the calculator. Again, doesn't hurt to go back and look. Make sure I didn't leave off a digit or double hit a digit when I entered those values. Okay. And then on this calculator, second stat, one variable stats, L1, frequency 1, always, and then calc. Okay. So we arrow down, and we look at the 5-number summary. We start with the minimum of 18. Q1, which is 18.5, which the minimum and the Q1 being so close tells us that it's pretty compacted on that lower end. Median is 20, and then Q3 is 26, and the maximum is 45. Okay. So that's what we have. So now we also want to go through and find the fences and any outliers, because we'll want to put that on our number line as well. So interquartile range, Q3 minus Q1. So in this case, that is 7.5. I feel like we just did this last time, and probably we did. I'm just repeating that. So we end up with 18.5 minus 1.5 times 7.5. So 7.25. Okay. Upper fence is Q3 plus 1.5 times RQR. 26 plus 1.5 times 7.5. And we get 37.25. Okay. And we look at the data and we say, are there any values lower than the lower fence? Any data values in this set of numbers that are lower than 7.25? No. The lowest one we know is 18. None of them are lower than 7.25, so we don't have any outliers there. Are there any data values that are higher than 37.25? Yes, because we know 45, that's our maximum. That's definitely higher than 37.25. So 45 is an outlier. We won't always have an outlier, but we always want to check if we have an outlier. Okay. So we have all the information now. So we want to take this information, the 5 numbers here, the lower fence, the upper fence, and the outlier, and put that all in a box plot. So I'm going to start us off with a number line. Can y'all hear my dog barking? My dog's already had a big day. The garbage man came by and he was really excited about that. He loves to bark at the garbage man, and then now he's just on edge for a bit after that because he's waiting for that guy to come back if he does, which he won't. But anyway. Okay, so we have a number line, and I'll actually have I don't know how I'm going to do it for this test on Canvas. I'll try to figure out something for this one. For Canvas, I'm actually going to work on that after class today, since my 11 o'clock class is taking a test. I'll work on how to incorporate all this in the Canvas, and if I have anything to report to you on that, I'll tell you on Tuesday. Alright, so we go ahead and mark our 5 number summary, which is 18. So 18 would be right here. I'm going to make it a little bit above the number line rather than on it, just to so we can see the entire box plot. Q1 is at 18.5, so I'll make a mark right next to that one, although it almost looks like 19. The median is at 20. Q3 is at 26, and the maximum is at 45. We draw a line connecting all 5 of those points. And then the middle 3 dots, vertical lines, and we close up those 3 lines, so make our box. Now, we go ahead and label the fences. Our lower fence is at 7.25, which I didn't really mark on our number line, but you can find it somewhere around there. Our upper fence is at 37.5, which would be about halfway in between 35 and 40. Yeah. And we have an outlier at 45, so I'm going to mark that with an asterisk. Okay. And so, hang on one sec. Okay. And so we have our box plot. Now, again, a couple of things we can tell about this particular box plot. Because the median is closer to Q1 than it is to Q3, and because our left whisker is a lot shorter than our right whisker, we can say absolutely this data is skewed to the right. Okay, so all the data is centralized here with the long tail to the right. That tells us it's skewed right. Okay. And again, that correlates, with the lower fence being much lower than the data set, and the upper fence being a lot closer, actually, with inside the data set in this case. So yeah, and as far as it being compact or spread out, because of our box is relatively small compared to what's on the right hand side. So this is 50% of the data inside the box, and the other 50% of the data is on outside of that. I don't know. It's a little bit spread out because the box itself is not all that small. I would say it's a little bit spread out. It's pretty close to being even, but not quite. And I think what we calculated before. Going back to our statistics, we had a standard deviation that we calculated of about 7.3, and our range was 27, and that divided by 4 was 6.75. So yeah, it was pretty close to being normally distributed. But we actually have a little bit bigger standard deviation than we have the range divided by 4. And based on our range rule, that ended up saying it was slightly spread out. Okay, and that's what's happening here if we look at this box plot as well. What would it look like? Yeah, we're doing fine. So if we have a normal symmetric bell-shaped distribution, back on my screen. Because we looked at two box plots that represent skewed data already. If it was a normal bell-shaped distribution, it would be something like this. In this situation, our median would be roughly halfway between Q1 and Q3, so that this line would be kind of in the middle of the box. Our whiskers would be about the same length, and our box itself would be roughly anywhere from 1/3 to 1/2 the length of the overall line. So it could actually be a little bit of a larger box, but that would still be considered a normal symmetric bell-shaped distribution. So everything would be nicely centered, basically. So that would be the third type of box that we might see, and it's not, all data sets kind of have their own thing going on. There's no guarantee it's going to fit any one of these shapes that we looked at. If we might see something like this, where the box, you have a shorter whisker over here than we have here, but the median is actually closer to the right hand side of the box. In this situation, it's actually harder to tell what's going on with the data set just by looking at the box plot, because the short whisker over here says it's skewed to the right, but the median to the right of the box means it might be skewed to the left. And in fact, depending on what metric we look at it, we may end up deciding it could be either one. That's why I would encourage you to use the comparison of the median and the mean to really decide on whether it's symmetric or skewed left or skewed right. This one is actually sending mixed messages. So anyway, that actually wraps up chapter 3 right there. As far as our test goes, I'm going to set it up as a quiz in Canvas. I think I've mentioned that already. And that formula sheet that I've uploaded to Canvas will be available as part of the test. Probably I'm going to try to make it an image file and insert that into the header of the test. We'll see how that goes. But if and we haven't looked at it recently, but you'll notice on here I've actually given you a description of making the box and whisker plot, similar to what we went over today. So this is all the stuff from the latter part of the chapter of the material. So the interquartile range, the lower fence, the upper fence, 5-number summary, and then the box and whisker plot. That's all section 4 and 5 right there. Like the range roll, we'll definitely want to use that. Figuring out the shape of the distribution. And some of these other things, like the mid-range function. We didn't talk about mid-quartile. That's another measure of central tendency we could find. It's just the two quartiles added together and divided by 2. And that's actually a pretty interesting number because it focuses on the middle 50% of the data. But yeah, it's one of those things we still don't use a whole lot. So all these formulas, that's what will be provided on the test. So anything else beyond that, you'll have to be sure that you know already, beyond what's on the sheet. I also have a sheet with calculator instructions, and that will be available it's in the Canvas files. We're going to do the whole thing on Tuesday, but I actually encourage you to work on it in between. That way you have an idea of what you're comfortable with versus maybe what you still need to work on some more. Because I want to give you all a shot to work on it first before I go over the whole thing, so you can kind of see where you stand. Okay. Plus, I think it'll help you study. Yeah. But I will work the whole thing during class on Tuesday. If we go into the files, I don't know if I mentioned it, but I did upload the review. Sorry. So it starts off with the chapter 1 problems, descriptive or inferential statistics, where it either describes or makes predictions. Qualitative and quantitative. Now I might change that to say categorical here I think I'm going to use categorical instead of qualitative. So I apologize for that miscommunication there. If we do have a quantitative variable, we want to also state if it's continuous or discrete. And so we have 4 different parts to that problem. And then observational study or an experiment, we have that. And then problem 4, that would be a matching problem, so we have 4 answers. Day of the test, I'll actually give you a window of about 6 days during which you can take the test, from after class on Tuesday until the following, probably Tuesday night, actually. So maybe a 7-day period. Anyway, you can take it any time between them, but you'll only have 1 attempt, and you'll have a time limit of 2 hours. So yeah, you can take it any time in between. So if you wanted to do it during Thursday's class next week, because we won't have a lecture next Thursday, that would be ideal especially for those of you that are in early college, high school. That way you can just take it during normal class time, and I give you a 2-hour window, but probably you don't need nearly that much time to do it. That's just to allow for any issues that may arise. So yeah. So if you wanted to do it during class time on Thursday, that's a good time to do it, because I know people have other work schedules and whatever else to worry about. But I also wanted to give you a window of time during which you could do it, just to make sure that if you had a time that you like better, or if you know that you have a day off on Saturday or Sunday, if you wanted to do it that day, you could. Yeah. So you have some options, basically. Okay, so it won't be a lockdown browser. It'll just be a basic Canvas quiz. I mean, the first question though will be on academic honesty, so I encourage you not to use other resources. But I mean, you'll certainly be able to look at the formula sheet and anything else. Okay. And then I've given you on this practice test, we have a data set of 25 values. And so these 25 values you'll basically use for the remainder of the review, and similar on the test. Organize the data with the stem and leaf plot. Fill out the frequency distribution with the frequency and the relative frequency. And this is where doing the stem and leaf first helps, because stem and leaf gets everything in order, and then you can just count up and put everything in here. Make a histogram for the frequencies. I don't know how I'm going to put this in here. And what I may do for this problem is I may make it a file upload question, where you just write it out on your own paper, and then take a picture or a scan of your work and upload it into the test. I don't know of another way of which we can do that. So that's probably what I'm going to do for that problem, and the box plot problem for sure. Yeah. These are basically fill in the blank problems. We have a 5-number summary, measures of central tendency, measures of variation, which I've called range, standard deviation, and interquartile range. Calculate the lower fence and upper fence. Are there any outliers? And draw a box and whisker plot above the number line. And finally, we have our analysis problems. Is the data skewed or symmetric? Explain and support your answer. So I'll leave you like a text box in which you can write or type in whatever you need to there. And same thing on 15. Is the data compact or spread out? It doesn't have to be compact or spread out. It may be normally distributed. It just depends on what the range rule tells us. Now, so when I say explain and support, just basically saying how do we justify this answer, and again, that's usually going to mean the range rule for number 15, and then our rule on skewed versus symmetric, where we just compare the median and the mean. Okay. So we might say it's skewed, or we might say it's symmetric because the median and the mean are approximately equal. We might say it's spread out because the range divided by 4 is less than the standard deviation. You know, whatever it tells us, that's our justification. But we want to make sure we do include that justification, so I can see why you arrived at that conclusion, and so on. And that is it. And this one has like the attachments for the formula sheet, because this is actually the one I would hand out in person class. I just saved the PDF for that. But like I said, that other stuff I'll include in the header of the quiz. Do you have any questions? So as far as the format of the quiz, of the test and Canvas, it's quiz and Canvas, but it's actually our test. But a lot of the problems are going to be like some of them are multiple choice, because if we ask whether something is a designed experiment or observational study, there's really only two options there, so I'll just make that multiple choice. Some of them are matching, like the sample techniques, those are matching problems. And then some of them are fill in the blank, and so I'll make a fill in the blank answer for y'all in the Canvas quiz. And then others are going to be short answer, or I'll just give you a text box like these last two problems to fill in. And then, like I said, the two graphs, the histogram, probably also the actually the I think for the stem and leaf, you'll be able to do that in a text box, so we may be okay there. Yeah. Anyway. So, yeah, it'll be a combination of different elements on this test, as you can see. But yeah, definitely file upload for the histogram and the box plot. So. Any other questions? Alright, I don't have any homework for you today besides just work on the review. And again, I encourage you to work on the review before we go over it, so you can kind of see where you stand going into this thing. And then when we go over the review on Tuesday next week, that'll give us a kind of a definitive answer for these problems, I guess. Anyway. I guess that's all we have for today. It's a little bit early, but I guess we can end it there. So, you all have today's Thursday, right? Have a good weekend, and enjoy the rest of your day, and I'll talk to you on Tuesday. Have a good one.